DC motors are widely used in many applications, from small toys to large industrial machinery. They work by converting electrical energy into mechanical energy through the interaction of magnetic fields. In this article, we will explore the working principle of DC motors. A DC motor has two main components, the stator and the rotor. The stator is the stationary part of the motor, while the rotor is the rotating part. The stator consists of a cylindrical structure made of laminated steel, which contains a number of slots in which the field winding is placed. The field winding is made of copper wire and is wound around the stator core. The ends of the field winding are connected to a DC power supply. The rotor of a DC motor is made of a cylindrical core with a number of slots that are parallel to the axis of rotation. The rotor core is made of laminated steel and is fitted with a commutator and a set of brushes. The commutator is a rotating switch that connects the rotor windings to the external circuit through the brushes. The working of a DC motor is based on the principle of electromagnetic induction. When an electric current flows through the field winding, it produces a magnetic field that surrounds the stator. This magnetic field interacts with the magnetic field produced by the rotor winding, causing the rotor to rotate. The direction of the magnetic field produced by the field winding depends on the direction of the current flowing through it. When the direction of the current is reversed, the direction of the magnetic field also reverses. This causes the rotor to rotate in the opposite direction. The commutator and brushes play an important role in the working of a DC motor. As the rotor rotates, the commutator switches the connections between the rotor windings and the brushes. This ensures that the direction of the current flowing through the rotor windings remains the same, even as the rotor rotates. The speed of a DC motor can be controlled by changing the voltage applied to the field winding. When the voltage is increased, the strength of the magnetic field produced by the field winding increases, causing the rotor to rotate faster. Similarly, when the voltage is decreased, the speed of the motor decreases. DC motors are used in a wide range of applications, including electric vehicles, robotics, and industrial machinery. They are known for their simplicity, reliability, and high efficiency. However, they do have some drawbacks. For example, they produce a lot of electromagnetic interference, which can interfere with other electronic devices. They also require a DC power source, which can be expensive to install and maintain. In conclusion, DC motors work by converting electrical energy into mechanical energy through the interaction of magnetic fields. They consist of a stator, which contains the field winding, and a rotor, which contains the commutator and brushes. The direction of the magnetic field produced by the field winding determines the direction of rotation of the rotor. The speed of the motor can be controlled by changing the voltage applied to the field winding. DC motors are widely used in many applications, but they do have some drawbacks. Despite these drawbacks, they are an important and reliable technology that has been used for over a century.